benvenuti a questo evento di letteratura inglese per la scuola secondaria di secondo grado. È su un tema che però è sicuramente di interesse più generale. Parleremo di neuroscienze. Il titolo preciso è Where Neuroscience Meets Language Teaching, quindi l'interazione tra neuroscienze e insegnamento della lingua. Avremo con noi Beatrice Baldi, che è studiosa di neuroscienze, e Leonard O'Sheen, insegnante di inglese, collega della professoressa Chini, che purtroppo oggi non può essere con noi per un piccolo inconveniente. Non ruberei altro tempo all'evento e lascerei la parola, se non sbaglio, alla dottoressa Baldi, che sarà la prima a parlare, vero?
Sì. Buon pomeriggio. So today I will present, are you able to see the slides? I hope so, yes. So today I will present a very broad and surface level, unfortunately, overview of neuroscience and the study of the nervous system. The idea behind it is to provide a glimpse into what neuroscience is, what kind of science it revolves around, and the types of interconnectedness between neuroscience and other areas of learning. So yeah, let's get started. So what's neuroscience? Neuroscience is, broadly speaking, the science that entails the study of the nervous system, which is divided into the central nervous system and the peripheral nervous system. So to give you a general overview of what that means, we're studying the brain and all the synaptic connections that go up until the very end of your limbs. Neuroscience is not only the study of how the nervous system works, but also how it is intertwined with all the other systems that govern your behavior and your emotions, your memories. To give you an idea of the scale at which we're talking, your brain has more connections than there are stars in the Milky Way. So if you think about the vastness of the universe and of the Milky Way, then comparing that to how tiny and how constrained the amount of neurons in the brain is, gives you an idea of how packed these cells are. So I've been mentioning neurons, but what are they? Neurons, also known as nerve cells, are the main players, the main role players within the nervous system and within our brain. So what do they do? Essentially, neuroscience is involved with the study of how the nervous system processes information. So the idea is all surrounding information flow and how this flow of information is enabled by connections within the brain through nerve cells. So nerve cells are composed, just like any other cell, by a nucleus, a cell body, and then they are very, very specific, as in they have differentiated from other cells because they have connections that are referred to usually as dendrites and axons. They are prolonged, essentially, parts of a cell which bind to other through connections which bind to other nerve cells and guarantee a flow of information. The idea behind it is there is chemical and as well as electrical information flow. And while electrical information flow happens within the cell, chemical information flow happens between two cells. So if we look at how two cells connect, we are looking at a synapse. So the connection between two cells occurs chemically. The chemical interaction between the two cells is enabled by a very tiny space between the two of them, which is referred to as a synaptic cleft. The idea is that two nerve cells don't touch each other, but there's a space in between them that is where the magic happens, essentially. So what happens is the information flows from the cell body. Let me go back. From the cell body, so from the center of the cell, up until the very end of the axon, towards the axon terminals. And there, where you find the axon terminals, that's where the electrical signal is converted into a chemical signal. So the chemical signal is happens in the form of vesicles, so essentially packed neurotransmitters that are transmitted from the jump, essentially, from one cell to the other in this space. And what happens is, if you think about all the neurodegenerative diseases or cognitive impairments, sometimes the reason behind why the brain might not be working as well as we hoped it would is because there's something going wrong in the way the neurotransmitters, so these chemicals, are being reuptaken within the synaptic cleft. So the idea is there are a lot of chemicals in this very tight, tiny space, and whether or not the other neuron is able to pick those chemicals up and continue the transmission is what defines a neural spike, so a neural passing of neural information. So where does this happen, and why is it connected to linguistics and neuroscience? So all of this happens in the brain, and the idea is, and throughout the nervous system, and the idea is it happens in areas of the brain in which neuroscientists have. No, it's not. Just to answer the last comment that I see, it's not going to be super scientific. I'm going to just give an overview, and then we're going to jump straight into the more connectedness with and connections with linguistics. So the idea is these connections that I described, they're happening mostly in certain very specific brain areas. So the picture that you're seeing on the screen is taken from Nature Neuroscience, so a journal article, and it gives you an idea of how vast language processing is in the brain. So there definitely are specific brain regions which are entailed with language processing. So you might have heard of Broca's area and Wernicke area, but the important thing that I would like you that I would like to stress and would like you to remember is this is not an isolated process. So while certainly certain neural areas light up more when we, for example, do brain scans, it's important to note that the whole brain is involved. It's a very, very frustrating misconception for neuroscientists to hear that we only use half of our brain, or like a certain percentage of our brain. No, we don't. We use the whole of our brain all the time, even when we're doing tasks that don't necessarily require a whole brain activation. The whole brain is still active. Unfortunately, this picture right here on your right was supposed to move. It doesn't because of the way this presentation works. But if it moved, you would have seen neurons interacting with each other. The idea is that they branch out and they connect. They essentially seek out connections. So they seek out to create the space that I was mentioning earlier. So they try and get closer and closer to each other to create connections that potentially could lead to meaningful insights. So when they tell you, oh, when you study something new, it might be difficult at first because you don't have those synaptic pathways formed yet. So that's the reason why essentially your brain hasn't connected yet in the way that allows you to process that information. But it will if you go through a process of recursive action. So if you practice something more than once, then this is telling your brain, oh, this certain pattern of activation should be something that we invest energy in. And when we invest energy, when the brain decides to invest energy towards learning a certain, whether it's a behavior, a language, a new skill, then what's happening is those connections are forming, and those neurons are seeking out to connect with other neurons. This is the reason why certain things that at first may sound difficult, or a language that at first may sound cryptic, ends up being a language that we eventually become fluent in. So as you can see, just briefly giving an overview, the main language pathways are found in the left hemisphere. So this is the reason why, for example, we see left hemispheric brain damage in people, and consequently language impairments in people with stroke in that specific brain area. So if you undergo a stroke that influences or damages that part of the brain, then you might not be able to process and be as articulate as you were before the stroke. And usually strokes have to do with basically blood flow in the brain, which is another key point. When I was mentioning the idea of energy required for brain cells to move closer together, it has also very, very strong ties with blood flow and brain regional activity. So when blood flows in a certain specific part of the brain, that means the brain is trying to rewire that area. It's also the reason why, interestingly enough, when we go through adolescence, we may find that, and this might be relevant for those of you who have children or who are looking back on their childhood, the reason why adolescents are usually referred to as very emotional and sometimes reckless is not because they are inherently emotional and reckless. It's because in that period of time, usually, what happens is the brain is trying to form meaningful connections in brain areas which are entailed with processing emotions. So there's a specific time in our life where we devote energy to specifically honing in certain skills. And adolescence is when, ideally, we develop everything that has to do with empathy and emotional regulation. So we may be quite emotionally dysregulated at some point because of this rewiring and this moment of chaos that's happening in certain brain areas. And this has to do with synaptic pruning, which I've always found to be a very fascinating topic. So essentially what happens, and I thought it was also interesting with regards to language, and I'll tell you why in a second, but essentially synaptic pruning is a concept, it's very simple actually. It's a concept that has to do with developmental neuroscience. So when we're born with an amount of neurons which grows exponentially. So the idea is our brain tries to create as many neurons, so as many neural cells as possible, to make sure that when we start to actually experience the world, so when we grow up a bit more, we're able to tune our brain and fine-tune those connections towards the most meaningful and most impactful life experiences that we will eventually go through. And what happens is during a certain age, which usually is around 2 years old, we have an amount of synapses which is baffling. It's really incredible. Our brain essentially are filled with potential connections, and only some of them will remain and some of them will be cut off. And what happens is the ones that remain and the ones which are cut off, how does the brain decide, which ones to keep? It basically has to do with your experience of the world. So your brain fine-tunes to the kind of life experiences that you go through. So for example, in the context of language, if you are born within a family that speaks a certain language, then only certain neural connections will be maintained that are beneficial to learning that language. And the other neurons that might have been more useful to learning a different kind of language, maybe based off of different grammatical structures, for example, or lexical structures, may not be required. So that's where synaptic pruning occurs. Pruning essentially means cutting off of synapses. So the brain understands that actually my language environment doesn't need that kind of synapse, so I'm not going to devote any energy to maintaining that. And what happens is it kind of slowly, progressively weakens to the point that it disappears. Disappearing, though, and pruning doesn't mean that it goes away completely. If later in life we decide to pick up a new language, what happens is we rewire the brain and a new synaptic connection eventually occurs. This is the reason why you may also hear that it's easier to pick up on languages when you're younger. Why? Technically, you could argue it's partly because of the amount of connections that we already have. So the idea is it's easier to use and strengthen a connection that's already there compared to creating a new one. We're very much able to do so, and I would like to stress that we are always able to create new connections. It might take us a bit more energy because we are creating as opposed to strengthening a neural pathway. I hope this makes sense. But the idea is we are able to, so we can and we should be definitely, and I'm encouraging you to pick up new languages even throughout our lifetime and even later on in life. And it also has an impact on the development of dementia. So studies have found that people who engage in cognitive activities which basically are more likely to create neural synapses, those kinds of activities are more likely to lead to a later onset or even delay completely the onset of neurodegenerative diseases like Alzheimer's, which I'm sure you have all heard of. So the idea behind what I told you before is certain brain areas are devoted to certain specific tasks. And while that is true, it doesn't paint a complete picture. And I was thinking about what I could tell you guys and how I could convey the idea that the brain rewires itself in an incredible way. And I thought I would just briefly give you an overview of a very interesting and, in my opinion, pretty poignant story. It's a story about a 40-year-old man, a French man, who was living his life in a very normal way. He had a family, he had children, he was working. He definitely wasn't a genius, but he had a decent IQ, so he was definitely able to perform most daily tasks without any type of extreme, cognitive loads. However, one day this man decided to go to the hospital, claiming he was experiencing severe migraines. What the doctors decided to do was to do what most neuroscientists would default to, which is a brain scan, a CT scan, which in very simple words is simply a scan of how your brain is. It's a very surface level scan before any other MRIs and all of that is even considered. So this was around 2007, I believe. What they found was that this man was missing 90% of his brain. And I remember hearing this from my professor. It was probably my first year of my neuroscience degree, and I was pretty shocked at the idea, at the realization that we're actually able to function cognitively as well as, consciously, even without most of our brain. So if you look at the brain scan that I put on the bottom right, you can see that this man has most of his brain filled with fluid. It's called cerebrospinal fluid. It's essentially a fluid that has to do with clearing of the brain in a normal circumstance. So when you sleep, this fluid helps with clearing up all the proteins and all the dendrites that are all the synaptic pruning that's been going on. So all the things that don't matter anymore. However, in the case of the story that I'm just telling you, this fluid was overwhelmingly taking over the brain, the man's brain. And the only part of the brain that was left was a little tiny sliver that you can see on the side of his left hemisphere. Interestingly enough, the left hemisphere is exactly the part of the brain where usually we think that the brain processes language. So the idea is usually our left hemisphere is the hemisphere that engages the most with language processing. So interestingly enough, this man was able to go about his life and speak and perform whatever tasks he had to, despite missing all of that amount of brain. And this begs the question then, what's happening? Like, what's really happening in our brain, and why was this man able to still, function? It all has to do with the idea of rewiring. So our brain is constantly rewiring. And I wanted to briefly mention, before I let the other speaker take over, dyslexia, which is definitely a very hot topic and a very interesting topic in the context of language processing. So the parietal and temporal lobe are the two main lobes that I'm going to briefly touch on that are influenced that dyslexia influences. The idea is that brain scans have found that there's a decreased activation and plasticity in those brain areas. However, interestingly enough, Broca's area shows much more, a greater activity compared to typical readers. So again, this ties to what I was telling you before about the man with missing 90% of the brain. The idea is that in dyslexia, the brain of a dyslexic reader, a dyslexic person, is rewiring to try and create a new brain area where reading is processed. So they may be slightly slow in reading, they may necessitate more energy, and they may require more time, but it doesn't mean they're unable to get to a point where they understand what they're reading. The only reason why that is because our brain is able to rewire. And so finding, when they did the first brain scan on dyslexic readers and the dyslexic brain and they went through several trials of children reading certain books and comparing brain activations between typical readers and dyslexic readers. They found that these other brain areas were activated, and that activation wasn't seen in typical readers. So this is also the reason why they might say that dyslexic individuals and people with dyslexia might be more creative. The reason why is because the brains of people with dyslexia are more likely to rewire in ways that a typical reader doesn't really even think of, which I think is beautiful. It's a way to reshape our understanding of what dyslexia is. It's not necessarily an impairment, but it can be seen as something that gives us somewhat of a superpower, as in we're able to see and process things in a way that maybe most people don't. And we're able to perceive things that most other people might not really think of, because of the way our brain is wired. So it's nice to have this view of dyslexia that influences linguistics as well. So yes, I think I'll pass on the word to my coworker, but I'm more than happy to delve deeper into neuroscience if you have any questions. I didn't want to go too much into the neuroscience nitty-gritty details, but I'm more than happy to talk about any specifics.
Thank you, Bea. Wonderfully interesting. And also, as a teacher, sometimes trying to find a neuron amongst a class of teenagers is difficult. It's nice to know that there are still some there.
Definitely.
The fact that our brain is a fantastic, complex, and fascinating, but also very mysterious machine was already clear in the 19th century when Emily Dickinson praised the human mind's capacity to imagine, perceive, create, and many more things, so much that it can be considered boundless and wider than the sky. But as we know, the processes of learning and teaching involves more than just the brain, neuroscience, psychology, education, social context, environment. There are many factors that influence the process. And as Prof. Perkins here says on the slide, without the whole picture, there is no whole child. This is the reason why combining all the things that Beatrice said before, we have the new and improved type of brain-based learning. It is scientifically substantiated art of teaching. It is the intersection of neuroscience, education, and psychology. And it is a paradigm shift from the informal education that we have up until now, the historical way of doing things. I know what you're thinking. Great ideas, great things, but how can we benefit from this? How can we practically use all of the new information that we have to enhance our lessons? We'll give you some hints and ideas, and I think you'll see that that it's easier than what you think. We know that one of the main issues we have in class is keeping the attention of our students. keeping the attention of our students. But there's a quotation that I find particularly interesting, that it is impossible for the brain not to pay attention. It is always paying attention to something. Unfortunately, sometimes it's not when we are speaking at the top of the class. But so it's not that our students are not paying attention. They're paying attention to something else. So what can we do to set clear goals, be creative, and when nothing is recognizable, create novelty? Okay, create novelty will draw their attention in. We don't need to completely, completely forget about our old systems or activities or way we do it, but we can manipulate them and improvise about certain things. Here we have 3 different types of ideas where we use gamification, jigsaw, and learning stations. Gamification is the simple use of games, designed elements in easy non-game contexts. Use leaderboards and badges to find out some like icons or hearts to vote for presentations, etc., using our our lessons as games, as competitions, if you like, to make it a little bit more fizzy for the kids. The jigsaw methodology is a cooperative learning strategy where students are divided into groups and each member becomes an expert on a specific part of the topic, and then the different parts of this lesson jigsaw come together to form a whole. Learning stations, specific areas within the classroom where students rotate through to complete different slides. And we'll look at each one of these in a little bit more detail now. So gamification, let's start with that. And so, as we said, the use of games designed elements in class. We know that grammar is probably perceived as the most boring part of our lessons, but it is the perfect field where we can test a bit of gamification. It's a very simple way of creating games because grammar has a certain set of rules. Whatever grammar topic you're teaching, sooner or later, there will be some time for practice. Practice using the rules that you have already taught in school. Instead of giving them a worksheet, cut the single exercises and give them the first part. When they've finished, you check that if it's correct, and you put these second parts together, and you can ramp up the difficulty level on the grammar grammar topic that you are studying, and then ramp it up again, the third and the fourth. This will not only help them get into solving of things, but they'll have their ideas primed and ready for more difficult challenges using what they have learned, the methods along the way. And grammar continues to become more and more complex as we're moving on through the different levels. Now let's look at learning stations. They can be used for any topic, but since we spoke about grammar, I'm going to show you something about, and now I'm going to show you something on literature. When you introduce a writer, in this case Shakespeare, divide students into small groups around the class. Each group has a booklet with some guiding activities, as you can see here. Oops, sorry, wrong. Okay. Prepare some stations around the class within the room that will help find the information needed for the booklet. Here's some examples. We have historical context, life, works, legacy, and these pieces of information will be placed on the 4 stations around the class. Then you can use the material you prefer, whether it be videos, textbooks, primary documents, handouts, whatever sort of information that the students are required to find, and ask the groups to choose one station and investigate the information on that station. Every 10, 15 minutes, depending on your time scale, the groups will rotate around the different tables, gathering the information that they need in each one to then have a whole at the end of the class. It is a fun, interesting way of the groups to gather each of the information and help them to remember that, we found it over there, we found it here. Oh yeah, that's right, that and that. Learn stations are perfect to introduce our next topic, which is multimodality. As we said before, if the brain detects novelty, it pays attention. Okay, so that since all learning occurs through sensory perception, combining the 5 modes of communication in one medium is a good starting point to grab and keep the attention. Once again, it's always about keeping the attention, trying to keep the novelty level slightly raised more than higher, and just engaging with the kids. We'll add one more idea for you in this case, for specifically grammar lessons. And the last topic is using post-it notes, transforming your grammar exercises into post activities which students can read, speak, write, and move around the class in the same lesson, perhaps constructing different sentences, constructing different ideas. Okay, so there we go. So neuroscience teaches us that the people remember best what happens first. So spaced learning here, which happens first, second best, what happens last, and least, what happens in the middle. So we remember what's happened at the start. We remember better what happens at the end, but in the middle, we kind of go, what was that all about? Okay. Spaced learning, in this case, is a technique that involves revisiting previously learned material at spaced intervals. The method suggests breaking a learning task into shorter, manageable sessions. Each session is followed by a period of time where the material is not revisited, allowing for an initial memory to fade. The learning material is then revisited in subsequent sessions, strengthening the memory and making it more resistant to forgetting. As Beatrice was saying before about the idea of reinforcement, strengthening ideas through repetition in this case. We know that when we try to remember new information, we repeat it over and over, either out loud or in our heads. This is the reason why thinking routines for certain things are extremely useful. Thinking routines are simple, structured sequences of activities designed to guide and support student thinking. The one that you see here is taken from a new LitHub by Rizzoli educational book. But if you want to find out more, you can check out the Harvard Project Zero website, and you'll find routines for everything, introducing, summarizing, linking ideas, etc., etc., etc. Last but not least, neuroscience tells us that learning pathways involves webs, not ladders. It's not a simple movement up and down. It's sort of like a lateral movement of learning. For this reason, the more connections you provide, the better it is. We're speaking here about things like interdisciplinary works, not only CLIL, but every time you have a possibility to build bridges between language and the rest of the world, using your language classes to learn about the world, you give your students an extra possibility to remember. For example, you're teaching daily routine vocabulary, and you can use some of the books that you'll find online. For example, One Day with the President, One Day with Santa Claus, etc. When you're teaching food vocabulary, we in class, we use this very, very often. We use a lot of, we have a system, a presentation where the kids have to do a Master Chef video. So we come in at the start of the class, and we have little bags of different smells, different foods. And we know that memory and smell are very, very connected. I don't know why I'm not in neuroscience, but I know that is true. You can ask Bea later. Okay, so when you smell something, you're very close to its memory. And so we bring in bags of different smells with spices of different ingredients. And one part of the lesson. Another part of the lesson is where the kids are required to create a dish. They go and they do their shopping. They take a video of themselves shopping, all through English. They bring it home in groups. They create a dish and a recipe, following a recipe, explaining each process along the way, cooking, creating, hopefully without burning kitchens down, which has happened almost twice, and then eating the food at the end. So all of the sensory parts of the lesson are there, and it's not something that is easily forgettable. This is a really good thing, and you can use this sort of idea for many different levels in this also. For upper levels and literature class, you can use working walls. These are interactive classroom displays designed to enhance learning. The ones you see here are the one on our quinte, in our 5th years. They're interactive and involving because the teacher only prepares the initial layout. It's sort of almost a blank page, and the students then add to these things as they go along. They add different here about romanticism, and they add parts along the course of a year. We have what books have you read this year, and this written on the board, etc., etc. They're interactive and involving because we only prepared the initial layout, but the C is the last one. The last one here is because it's partially incomplete, because the students are asked to complete and interact with the wall, not only to write facts, but as they choose the best quotes that they find as they're reading the books. With small groups, they complete the different activities of the wall using pens, pencils, post-it notes, etc. And this helps them create a visual web. And for them, it makes it easier to remember, not only just through simple repetition, but by being able to associate design or visual stimuli with also what they're trying to learn in these cases. And I spoke too quickly, and now I'm done. Thank you very much. And if you have any questions.
Grazie Leonard. Avevo visto una domanda nella chat della professoressa Giada Zichitella. Is it true that the Broca-Wernicke model is now considered old-fashioned and that language is implemented by many complex neural webs, including subcortical areas? Credo che Beatrice Baldi forse sia più interessata a una risposta scientifica.
I'm happy. Would you prefer for me to answer in Italian or English? Is that?
Maybe in English.
I don't mind. Okay, great. So yes, to a certain extent, it is true that Broca and Wernicke areas are involved in language processing, and they still are to these days considered the main areas where language processing and deciphering occurs. So yes, it's not completely outdated. That being said, very interesting studies have found that I'll give you an example, different languages activate brain areas which are profoundly different. So they've looked at the brain scans of people speaking German and brain scans of people speaking English or Italian, and they found that the brain activation patterns are profoundly different. So while certain conserved areas are certainly identifiable, which are Wernicke's areas and Broca's area, then it's not entirely true that that's where language processing occurs. So the idea is that's where part of the language processing occurs, and certainly those are conserved among most individuals. But yes, subcortical areas are involved. One of the slides that I showed initially showed the middle picture with Wernicke and Broca's areas lighting up, but also on the sides, if you remember, there were other areas lighting up in different colors. And the idea is, depending on what language you speak, certain brain areas might light up more than others. And this also ties quite nicely with the idea that learning more languages shapes the way in which you see the world. Yes, it does. It literally rewires your brain in different ways. So the idea is, by learning more languages, not only are you able to obviously articulate yourself better and being able to describe things perhaps differently, but you're also creating connections that would not be there otherwise. And having more connections within your brain allows you to do all that interdisciplinary work that Leonard was talking about. So I hope this kind of answers your question. Maybe I could link it to synaptic pruning as well, that I was mentioning earlier. So the idea of a lot of synapses being there. This might be useful for more classroom-based activities. Those children which have autism or are on the autism spectrum, for example, they have too many synapses. So and too active at the same time. So the idea is that synaptic pruning didn't occur as well and as specifically as in most other brain and in the brains of most other people, especially people who are not on the autism spectrum. So there's a very specific interplay between having connections between brain areas and having a really well intertwined brain, which is awesome, which is wonderful, and it prevents neurodegenerative disease and all sorts of other brain dysfunctions. But there's also a fine tune and a fine line that doesn't need to be crossed, otherwise you end up with neuropathologies that have to do with brain activation. So if your brain is too active and it doesn't have this filter, then that's where you start to shift towards either being on the autism spectrum or other cognitive impairments. I hope it answers your question more broadly. Does it? Yes, amazing. I'm glad. There's a question about ADHD. Oh, I can't hear you. Your microphone is.
Thank you, Beatrice. Another question from Professoressa Anna Mantese. What are some useful methods to teach grammar to ADHD or dyslexic students to overcome their difficulties in managing theoretical rules?
So, something I could mention here is ADHD has to do with the dopaminergic system in the brain. So in very simple words, I don't want to get too into the neuropharmacology of it all, but basically our brain works with different chemical signals, the ones I mentioned earlier. And the idea is that they're not all the same. And according to the difference in chemical structure and in location within the brain, we can identify different types of neurotransmitters. One of the key types of neurotransmitters that is dysregulated in ADHD is dopamine. You will definitely, especially as teachers, you will definitely have heard of the idea that we are hijacking our dopaminergic system because of the constant scrolling and constant engagement with all those internet activities that are currently on the rise. It's true. To a certain extent, it is true, and it has to do with our dopaminergic system being constantly activated in a way that dampens it down progressively. So the idea is, if you overuse and if you stimulate certain neuronal patterns, then what happens is they're less sensitive. So we get to a point where like doom scrolling or all those activities which have to do with constant reward systems, which are obviously tied to dopamine, lead to a less sensitive dopaminergic system. So in ADHD, what happens is dopamine is dysregulated. So they go through, obviously there are differences even within the ADHD spectrum, but more broadly, there are, I don't want to go too much into details, but there is evidence that what happens is during certain periods of time, there's too much dopamine. It is not in the right location, or perhaps not as strongly reuptaken by the neurons. Essentially, it's released, but the neurons can't really, either it's not enough or they can't really reuptake enough. So to tie it to learning, what you could do is focus on short, intense bursts of activity. So for example, for ADHD individuals, for ADHD children, what you could do is provide examples and give a lot of breaks in between. So for example, you're trying to teach, you were mentioning theoretical rules, you're trying to teach a certain grammatical rule. What you could do is very concisely summarize it and then give them time to process whatever has been said, and then once again go through an intense shorter period of time where you briefly condense all the information, and then you go through another period where maybe you're leaving them time to work on the worksheet or do some more work. So you're breaking it down into more manageable chunks. And obviously this is quite superficial, but trying to engage with them, trying to leverage attention. So tying it to something that might spark their curiosity. So tying a certain theoretical rule to something that they might themselves be very interested in might work. So yeah, this idea of bursts, like leveraging the bursts of activity. So leveraging these intense short periods of time where you explain something and then you leave some time. I hope it helps.
Grazie Beatrice. Sì, decisamente una risposta esauriente, direi. Al momento non vedo altre domande. Se posso farne una io, a chi vuole, diciamo, dei due, come interagisce il concetto di intelligenze multiple, diciamo, con questa relazione tra attenzione, leva emotiva per memorizzare qualche cosa. C'è una spiegazione scientifica o sono, diciamo, teorie psicologiche ancora da diciamo, da attestare a livello sperimentale?
Something I could mention in this regard is that we tend to remember what we load with emotions. So the idea is that when we talk about emotional intelligence, so when we talk about the idea of being emotionally able to detect what other people are feeling, emotionally able to understand and be empathetic towards one another, that has strong ties with memory. So there's evidence that if certain experiences that we go through in life are very emotionally rich, we're more likely to remember them. So here also is another thing that I could mention, and that is that neuroscience and psychology are different. So the theories of intelligence are more tailored towards psychology, and psychology is this theoretical study of our behavior, while neuroscience is the study of what generates that behavior. So neuroscience studies the brain, the nervous system, what begets the behavior, while psychology looks at the behavior and tries to create these frameworks. And so there isn't a perfect correlation between emotional intelligence and a certain part of the brain, or emotional intelligence and a certain neurons, but there certainly are strong ties with things like being emotionally intelligent and loading, so being aware of your emotions and being able to process them, and also remembering things. So this is why we remember what we load emotionally. That's an example of how a type of intelligence can interact with memory, for example. I don't know if that answers your question.
Of course, thank you. There is a last question from Professoressa Angela Guglielmetti. Can the excessive exposition to videos and screens of today's teenagers somehow interfere with the creation of synapses? Ovviamente anche il professor Oshii può dire la sua, essendo in contatto con gli adolescenti della scuola di oggi.
Honestly, I don't see how it can't. But I think this one, the creation of synapses, is certainly neuroscience rather than teaching. I don't understand how it cannot affect the brain and the very small sort of attention spans that possibly we are seeing in schools nowadays, where people's attention spans are a lot less than they used to be. So that as a teacher looking at students, I would say for sure there is some sort of correlation between it, but biochemically, I'm afraid I will once again ask my very learned colleague here.
Okay, not only students, adults too. Adults too. What has Beatrice to say about it?
What do I have to say? I would say that it's true. It does, to a certain extent, definitely influence synapse formation and synapse strengthening. To be more specific, what it actually influences is the amount of activation. So what I was mentioning earlier about doom scrolling, so the idea of, for example, TikTok, Instagram, and all those platforms which are based on the reward system that constantly gets triggered, because obviously we're constantly engaging in this loop of, oh, what's going to happen next when I scroll? What kind of colorful image is going to pop up? What kind of emotional stimulation will I get from reading certain comments? So what it does, rather than directly influencing synapses, it influences the amount of, for example, dopamine that's released and the amount of activation that the synapses go through. This also means that at a later stage, it will influence what synapses are strengthened and what aren't. I also would like to stress, and maybe this is going to give a more optimistic view on what's happening with the current technological advances, that what I was mentioning earlier about the brain being very plastic and being able to rewire itself is true, and it can be applied to this as well. So going a week even without constantly, checking internet and going through the doom scroll that I was mentioning is definitely doing something to your brain. It's basically recalibrating your dopaminergic system, the one that's dysregulated in ADHD, for example. And it's helping you to be more sensitive, again, to resensitize your brain to the stimuli, and so to be able to maintain maybe a greater attention span, being able to study for longer, and all of that. So yeah.
Thank you. A last request from Professoressa Giada Zecchitella, if you could suggest some books which are specifically useful that could translate neuroscientific findings for practical teaching strategies in the classroom. That is something we could communicate later, maybe, if you don't have a size bibliography now to indicate. Well, if there are no more questions, I think we could thank our guests, Beatrice Baldi and Leonard Oshii. We would like to thank all the teachers who took part in this webinar, and I would wish you a nice evening and see you next time with a new event for Rizzoli Education.
Thank you.
Good evening. Bye-bye.
Good evening.